So we're going to talk about pedigree analysis in this video. We're going to talk about how we can use family histories to determine how a trait is inherited. So we're really interested in this course in three possible types of inheritance. There are others, but here we're just going to focus on whether something is autosomal dominant, autosomal recessive, or sex-linked recessive. If it's sex-linked, we're assuming that the gene is going to be on the X chromosome. We are not going to do Y-linked inheritance here. So in order to really benefit the most from this video, I definitely will recommend that you will have seen the other videos that I made, the one trait, the two trait, and the sex-linked discussions, because I'm going to be building off of those. So we can just sort of say that looking at this pedigree, looking at this family history, there is evidence that the trait here, people who show the trait in their phenotype are in black. I will always give you a legend with pedigrees to make sure you know what represents what, but circles do represent females and squares represent males. So there's a lot of evidence in this family tree in just 3 generations to suggest that whatever this trait is, having the trait is the dominant allele and that it's on an autosome, not a sex chromosome. So let's kind of walk through what the evidence might be there. The principal evidence for autosomal traits is that if they're on the autosomes, that means they should be about equally present in males and females. They don't have to be exactly equal, but in general it should be pretty roughly equal as compared to something else we'll talk about soon. That means that should be because there are 2 of each chromosome in the autosomes in both males and females. There's no reason why they should have it in different numbers. It's also dominant in this particular case, having the trait, because we see it in every generation. So it's hard for a dominant allele to sort of be hidden in generations throughout the family history. All right, this, on the other hand, shows evidence of being autosomal and recessive. Autosomal, once again, because maybe it's about equal by sex. I know there's 3 males showing it here and only 1 female, but I'll try and give you pedigrees that leave you no question as to the fact that it's autosomal. Recessive in this case because it skips generations. So unlike what we just said with dominant traits, if the recessive allele means having the trait, then it might be hidden from generation to generation as it is masked by the dominant allele, which is not having the trait. Finally, there's sex-linked recessive, and really the hallmark of this type of inheritance is that we see it predominantly in males. This particular pedigree shows it completely present in males. However, don't let that don't be too extreme. Females can show sex-linked recessive traits. It's just that we'll see it overwhelmingly more often in males in this type of inheritance. So we might give you problems where we give you a sample pedigree and we ask you to first of all identify the pattern of inheritance and then perhaps to identify the genotypes of certain people in the family. So for example, what is this pattern of inheritance based on our clues? We see that it's about equally represented by sex, so it's autosomal, and it seems to have skipped multiple generations in this family tree, so we're thinking that it's autosomal recessive. If I ask you questions like this, I would highly, highly, highly encourage you to make a legend right away. So if I also asked you to identify the genotypes of these 2 people in the family, make a legend. Tell yourself that in this case, maybe the capital letter is not having it, since having the trait we determined is autosomal recessive. So the recessive allele would be having the trait. So can we figure out who these people are? Well, hopefully the person 2-1 over here is pretty easy to identify genotypically because they have the trait, and the only way they could have the trait is to be homozygous recessive. So that person's pretty easy to identify. But what about his mother? His mother potentially could be 2 different genotypes. Potentially she could be heterozygous or she could be homozygous dominant. And not have the trait as she shows. And then so what we need to do sometimes when we get questions like this is we need to puzzle it out. If she were homozygous dominant, then maybe you could establish for yourself that there's no way she could have any children that show the trait themselves. Let's say that she's homozygous dominant and her husband is heterozygous, which is what he could be, then all of the children would show the dominant phenotype, not have it. So really the only way that they could have this son that has the trait is for both of them to be heterozygous. So we do want you to be able to reason things out like this in pedigree problems, and really this is showing sort of all of your inheritance skills that you're hopefully building along the way. All right, let's do another trait. Let's say that this is a family tree. I see evidence that males and females both have it in roughly equal numbers, so we think it's autosomal, and this time we see it in every generation, so we're thinking that the trait is autosomal and dominant. So once again, if I ask you to identify these people in the family genotypically, make sure you make a legend. Why make a legend? Because now the dominant allele is having the trait and the recessive allele is not having it. If you do a lot of these problems in a row, you're going to confuse yourself very fast if you don't make a legend. So let's start figuring out who people might be. I would say that this mom up here is actually the easiest to identify now because she does not have the trait, and the only way she could not have it is to be homozygous recessive. All right, and then we're also asking you to identify her son. Her son has the trait. He can either be homozygous dominant or heterozygous. It looks like he did marry someone who doesn't have the trait, so she's definitely homozygous recessive. And it looks like they had 3 children, 2 of which have the trait, but 1 of which does not. And hopefully, again, you could convince yourself that the only way they could have a son that does not have the trait is for dad to be heterozygous. He cannot be homozygous dominant. So reason these things out, make a legend, take your time, make Punnett squares if you need to. Let's do one final one. Here's the hallmark of a trait being sex-linked and recessive. We see it entirely represented in males, or at least predominantly so. We also want you to identify these people genotypically. So whenever a trait is sex-linked, we need to draw the X chromosomes in, because remember that this trait is only on the X chromosome. And so we're only going to work with sex-linked recessive inheritance, so the lowercase allele is having the trait. So we want to identify mom up here. Mom does not have the trait, does not show having it, so again there's really 2 possibilities for her. She could either be homozygous dominant or she could be heterozygous. Now she had 2 children with her husband. She had a son who has the trait and a daughter who does not show having it. Dad is pretty easy to identify. He's XY, and if he doesn't have the trait, he has to have just a dominant allele. So how could they have had a son that has the trait? Mom had to have been heterozygous, not homozygous dominant. And then we also want to identify this male down here. This male does not have the trait. So what's the only way the male could not have the trait? Males are always XY, and if he does not have it, he must be capital T. I messed up there. He must be capital T to not have the trait.